Hey, hi everyone. Am I audible to the back? Yeah, nice. I have a complaint to you guys that Manoj's presentation was so good. I was enjoying, but you guys are not clapping enough. That is not good. There's such a detailed architectural diagram and all he drew is such a good thing. But so I'll start. The presentation title is a catchy one. It's called Migration Dreams, Zero Downtime, Maximum Impact. And myself, Kunal. I am based out of Bangalore right now, and I run a couple of community like this, like Sanchit. And it's nice to be here in Mumbai for the first time in my adult life. So from yesterday, just to share on a personal note, yesterday I've been traveling a lot, and I just had slept for like 2-3 hours yesterday night. So from every airport I am hopping, 2 hour, 1 hour time I'm getting yesterday. I'm just working on this same presentation. It's my bad, I procrastinated. But nevertheless, so I work as a developer advocate at CastAI, and I lead the APAC region. So I think each of us who are here, we have been working with EKS and all other AWS services. So the learning curves on Kubernetes like this. Okay, it's very hard, very hard. After some time, it's become, okay, I know everything. It's the easiest thing on the planet, right? So a lot of people feel the same thing, like Kubernetes is maybe not a fresher or who are starting. That time it like looks like a lot hard, but after some time we come to a feeling that okay, I know Kubernetes, what is it and how it works, what not. So that's it. But when someone says to me, okay, Kubernetes is easy now, we have a lot of automation and EKS, auto mode, Carpenter and all. I show them this. So this is the CNCF, project kind of a thing. So there are a lot of projects are there, and predominantly what these are built, to help add some feature into existing Kubernetes, fix some bugs that are still there in Kubernetes, and whatnot to extend the feature set of Kubernetes, right? And this is quite a lot, right? I think everyone would agree that this is quite a huge thing, but this is not it. We have a second page, third page all together. So now, if someone says like Kubernetes is easy, show them that this is the project, this is a partner that we have in CNCF. It's rapidly increasing. I think just last week we have some 3-4 projects into Kubernetes added. So now how to handle all this zoo, all the stuffs. So either you need a crazy CLI skill, so you don't need any other projects. You can handle by kubectl commands, you can handle everything. Or we can use automation or AI per se, and leave some of the easy work into AI, let them do the stuff, and we can rest a piece. So now automation, when I just showed the slide, one guy came to me, I was talking in Singapore, one guy came to me, hey, automation will do it, then DevOps engineer job will go, right? Then AI engineers will exist, and LLM will take a job, but that's not a way. So there are some things that I wanted to show, which can really be beneficial, and it's not really good for an engineer to stick on and work on these things. First, when you are deploying something into Kubernetes, the size of the instance, the number of replicas that you are going to use, not the pod replica, the node replica that I'm talking about, and how you are going to use it, what your application needs. And another thing comes into the picture, like you have to bin pack all your pods into nodes. So by default, Kubernetes, what is that? It scatters your pod across different nodes, right? We do not need that. That actually kills the whole purpose of being efficient. Thirdly, there are spot instance. So AWS has a lot of infrastructure, physical server that they have already purchased and that they were leveraging. But sometimes what happens, we as a customer might not use a certain GPU or certain CPU. What AWS does, AWS sells those things as a 90% discount. That is called spot instance. And why it's called spot? Because it's spot in nature. So they can take it out with a 30 second of buffer time. So they will tell you, okay, you have a time, 30 seconds, move your workload. We're going to take it, someone already purchased it. So the spot instance is very useful because it's a 90% discount. We can leverage it to reduce cost and do a lot of things. But the problem is definitely it can be taken away. And second is because by nature upfront we are paying to cloud before we start using, right? Or see, if you say like, okay, I use something like pay as you go subscription, okay, I use it and pay it. But it's not like that. You are committing, okay, I will use this much, this much, this much. You are planning something, then you are paying. Whenever it happens, it's not a post-paid connection of a thing. Like you pay, okay, you have forgot, and it's already meme culture, right? I forgot to pay my bills on AWS, now I am a beggar. So that should be avoided. We should, stop cloud waste. And again, like there's a question like Kubernetes is, by default, it's, efficient. So I have a, this is internet is not slow, so I'll just move to something. See, you guys can help me out, okay? Just scan this QR. And the question is very simple. So what is the average utilization of a Kubernetes cluster? So when I'm saying average utilization, I mean like the CPU utilization. So what do you think? Like if you have a cluster and that cluster is using multiple CPUs and all, so what do you think the average utilization should be? Now think of it in another perspective. This means like I am paying for this amount, okay? I'm committing 100% of the amount where I'm taking a CPU or a node from AWS. How much of that I am using actually in our workload? So I think just let's wait 1 minute. Is it that my internet is bad? Everyone is answering quickly, and I could not get it done something. Okay. Okay. So yeah, some people are saying like we can conclude like it's a 30 to 50%. The majority of you are voting. But think about that number, 30 to 50%, what does it mean? That you are paying, suppose, $1,000 for a N58 GPU, N5D node, and you are only using 30%. The 70% of the cost is going for a toss. Average means most of the time, I would say, most of the, except a certain spike, most of the time average you are using 30% or 20%. Still, like if you are using like 50% of the whole CPU of that you have available, then you are wasting 50% of the cost. Now, I'll just go back to my slide. Okay, so as per the latest survey, it is 10%. Now, why it is 10%? Maybe because you have seen a certain spike on a Black Friday sale or somewhere around, then you have set the request like that. But across organization survey, it is 10%. Last year, it was 23%. So it is getting worse and worse. The more AI workload, GPU workload is coming. We are purchasing lot of nodes, lot of CPU, lot of GPU, and we are only utilizing 10% of it. And the memory utilization is at 23%. Now again, I am not worried much about memory because anyway, it's quite cheaper than CPU. But think about the scenario. You are using 10% of what you have procured. So you are, efficiently, what I can say, like we are basically wasting 10 times of the cost that we should pay to the AWS. Now let's talk about infrastructure for a minute. So in infrastructure, Kubernetes, by nature, it tends to distribute workload across different nodes because it was built for scalability, right? So Kubernetes was built for large scale. When something happens, you should be able to, divert the traffic to another node, another region, another availability zone, and whatnot. And node cost us a lot of money. So now, underutilized node, if you are not, utilizing the 10% average utilization and 90% average time, we are just wasting resources. Now, if you see what I just did, these two pods were part of node 2. By common sense, what it tells, like I can just move this pod to node 1, correct? And what exactly happens? I'm not paying anything for the node 2 now. That's the common sense. And what we just did, I killed the pod that are there in node 2, I moved it to node 1. And that, essentially, I am just having node 2 node and I'm, all the traffic are going there. And this is called an algorithm that decides which node to use, which pod to, schedule on which node, and all these things are getting decided in the backend. Now, secondly, after just applying this only just that thing, just smartly deciding at which node to place, this is the data from a client. So the blue line indicates the provisioned CPU for a cluster, and the yellow line indicates the requested one. Now, if you see, it does not match. Sorry, the yellow line indicates the used one. So why it does not match? Because sometimes, developers, they are very lazy. They'll put high number of requests of a CPU. Okay, their application is running smoothly. No one is noticing that, okay, it can run a little bit less number of CPU as well. By doing the optimization, what we can do, we can essentially reduce the number of provision based on the user. So if you see there is a spike, that time we can definitely increase the number of CPU, but most of the time we do not need the higher CPU. Now that's a part of the workload on node. Now let's talk about pods, right? So there are two ways automatically is there in Kubernetes. There is called HPA, horizontal pod autoscaling. What it does, you have a pod, you need another pod, it creates another pod. Another pod, another pod, another pod, and like this goes away. Now there is something called vertical pod autoscaling, and recently in the Kubernetes 1.33, now we can in place vertical scale up also. Now what that does? So you have some pod that consuming 2 GB of memory, and that pod needs to scale up. So rather than creating another instance of a 2 GB pod, we can just buff that pod up. So the 2 GB becomes a 4 GB pod, and that way we can easily manage. Now just go by the example that I have given earlier. So we have 3 nodes, and what I will do, we can just easily this 4 pod we can move to node 1, right? Company, I know it's an imaginary situation, but thinking that all these are 2 GB, 2 GB pod, a node is like 10 GB. So I'm just moving that. So by moving that, again, I am saving 30% of the cost that I am paying before. So this node is become useless now. And now think about a scenario, the pods A that is there or pod G that is there, that might not need the 2 GB. It is not remotely possible that all the pods that are there, it will need a certain memory all the time. That is also based on the nature. You have deployed a Python application, that might be sometime, working a little bit more, that might need a little bit more CPU, and sometime it might not need. So now you can scale up and down, vertically scale up and down also. So if we do that, now what ends up happening, I am freeing up node 1 and node 2, and now only I have just node 0. So I'm paying for one node, and I killed node 1 and node 2, and by doing that, I'm just saving a lot of cost. Now everything is fine, I think, but there is a problem. There's a major problem in Kubernetes ecosystem itself. So there are a lot of workloads that we call as stateful workloads. And stateful workloads are there, it should not be there. Why? Because most of us, when you think about Kubernetes, we already have an app that we used to deploy first in Windows Server. From there, we moved to VM, and now from there, I'm Dockerizing and deploying it. How many of you have seen before adopting Kubernetes, the application development starts again happening? But it should be. In Kubernetes, any pod that is there, it should be killed anytime and created anytime without downtime. But that does not happen. We still again have the same Java application, same Python application that we deploy that is attached to a DB. The DB goes away and we are done. So now these are node pods which what happens, like we can't kill a node if we schedule one of these pods into that node. Now to avoid that, there's a thing called live migration. It's available from last 1 month. What does it mean, live migration? So the ability to move pods in same cluster between different nodes is called live migration. Now we can do that, right? We can kill a pod here and create another one into another node. But again, that kills the purpose. What will happen if we have a process running into pod 1 into node 0? Suppose this process has completed to 50%, 60% of the process, and then you kill it. Then again a new pod comes up. It will start from 0. I think many of us have experienced something like that when we make payment or something like that, right? At least once in our lifetime we saw like payment got deducted, but the money has not reached to the server. It has happened to many of us, right? So in this scenario, if you see, the service is online. The server is always running. The time you paid, and there is certain burst of offline, maybe 1 second or 2 seconds, and the server again came up, but it did not persist the transaction that was happening. You should have a little bit what I call it, maybe a loading screen. If it loads for 1-2 seconds, you should be okay. But the transaction happened, it got deducted from your bank, and it did not reach to the server. Is a big problem. To avoid this problem, we have something called container live migration. Now I'll just show a childish animation to just prove it. So I have a pod there on node A, and the internal IP is 100.15. I ask that pod to move to node B. So suppose the node A has some problem, I need to kill the node A. And then migration starts. Check this thing, that pod name has been changed, a pod that 123 to 123 clone 1, but the internal IP stays same. Now, why the need of internal IP to stay same? That's what the TCP connection matters. At level 3 or 4, it still holds the connection to the new pod, and the process starts in the new pod, okay, without any interruption. So now I'll just give a small demo. Okay, demo is 2 slides later. So why we need this in Kubernetes environment? I think I have explained it. Basically, to avoid this kind of stateful workload scenario. But let me see if the demo is running. The internet is a little bit choppy. So this is a game that I have deployed into Kubernetes. And at the bottom, if you guys can see, this is the server or the pod that is running. IP is 61.56. Some of you guys, like, I need 4 players. If you can scan and join as a client. So I'll try to migrate the pod live. So I will show you how to join it. So I'll just copy the URL. You have a mobile laptop. Everyone from it. So click on connect to server and click on this server. So yeah, I'm inside the game, right? And I can just normally play. Okay. Now you see here it is showing like 200 millisecond latency is there. It is connecting to the server and getting the data. And I think only you guys are not interested in playing or what? Okay, yeah. Some guys I have seen, I need minimum 4 players divided into 2 teams. And once the guys are joining, right? What I want to see, like this is the node, the green one. So the node IP is 55.102, and this pod, if you see, it is running on 55.102, and the internal IP is 61.56. And I think, yeah, guys are playing. You can see like a lot of players are playing. Even if I go to the game, okay, see here some guys are roaming around. Nice. So what I will do, I'll just click on the other node. So the migration gonna start. Keep the IP in mind, it's 61.56, and I'll go back to my game as a client, and I'll keep on playing for some time, and I can see some players are running around that side. Okay, I'll just go back, and the migration has happened. The internal IP is still same, but the migration has happened from 102 pod to 210 number of node, 102 node to 210 node. Without the interruption, all the players that are there, that are still connected, still playing and persisting the state, without any downtime per se. And if I just kill the pod and moved into another node, all these players would have lost their connection state and they would have to start again. This is the beauty of it. I'm migrating, keeping the internal IP same, and still people are connected. They are able to enjoy the game without any problem. And you see the benefit of it. 16 players right now connected and playing, and I can just migrate again. Even what I've tried, few days back, I created this button. What it does, every 20 seconds it just migrates. And 500 plus players were playing the same game, and it migrated 17 times without a single player dropping from the server. So that's the beauty of it. Wanted to show you guys now. So now where it works, good thing we are at AWS community today. It works on EKS. It's available there. GKE, I know we're not allowed to talk about this, or it's so fine. So GK is coming, Q4, and AKS we'll see. And so yeah, some of the use cases, we can migrate state instead of killing the pod and creating again. And we can keep the TCP sessions. Operation is easy. And now, see, here I am doing it manually, but definitely at our use case, we do it automatically. So you're using Spot, something goes wrong to the Spot, it automatically migrates without interrupting your workload. A lot of old thing that we have seen, a lot of banks are using, very old application, JV monoliths. Those you can migrate. You can bin pack easily into a single node. You have some, stubborn old workload that is not ready to move. You can just migrate it into a newer node without interrupting the workload. And those workloads, we have seen, probably many of us seen some database that runs on a single replica. It won't create another replica. On a single replica, it will run, and it will bother you for your life. Those pods now can be moved into other migration by using migration to other node. So yeah, I think I finished quite early. So we have a booth. If you want to see a demo, I have a workshop also, and I'm giving you some raffle. Come to our booth. And this is me, Kunal, signing off. And if you have any doubt about it, if you want to know about it more, follow me, ping me. I'm available. And thanks. Thank you, everyone.